Okay, so let's start doing some examples. So we're going to apply the power law of logarithms to help us go through some of these examples. And so the first question asks us to evaluate. And so what we're trying to solve for is the value of the logarithm. So here I have log base 3 of 9 to the exponent 4. So because the result part here has an exponent applied to it, I can use the power law of logarithms. So just to remind you what the power law looks like. Log base b of x to the exponent n is equal to n log base b of x. Okay, so I'm going to take the exponent part and use it as the coefficient of the logarithm, and then use that to help me evaluate. So here I can rewrite this as 4 times the log base 3 of 9. Makes my work a little bit nicer. And if I continue to simplify this, this is like log base 3 of 3 to the exponent 2. And so the exponent to which I need to apply 3 onto 3 to get an answer of 3 squared is an exponent of 2. So 4 times 2 gives me an answer of 8. Okay. Taking a look at the next one, again, I have an exponent on the 8. I'm going to use that as the coefficient of the logarithm. And I get 5 times the log base 2 of 8. And again, at this point, you should be able to recognize what exponent you need to apply to a base of 2 to get an answer of 8. And I know that that exponent would be an exponent of 3. And so I get a result of 15. Let's take a look at the next one. In this case, again, I have an exponent applied to the answer part. So I'm going to use that as my coefficient. And I get 2 log of 0.001. Now in this case, you don't actually have to think too much about your logarithmic part here. Remember that when there is no base written here, it's understood to be a common logarithm with a base of 10. And so anytime you have a common logarithm, you can use your calculator to help you evaluate. So I'm going to find the common logarithm of 0.001, and I get a result of -3. So that's 2 times -3. So log of 0.001, according to my calculator, is -3. And this makes sense because 10 to the exponent -3 gives me a result of 0.001. Okay, to finish this off, I get a result of -6. And we can check that again on the calculator, because this one I can type into the calculator. And so if I look at 0.001 squared, and I find the logarithm of that, and you'll notice that my answer is -6, which is exactly what I got here when I applied the power law of logarithms. Let's take a look at the next one. This one's a little bit different. You'll notice that I have a square root on 125. So I can rewrite that as an exponent instead of as a radical. So I'm going to rewrite the square root of 125 as 125 to the exponent 1/2. So this is going back to grade 11 when we looked at radicals and rational exponents. Now that the answer part has an exponent applied to it, I can use the power law of logarithms, and I would get 1/2 log base 5 of 125. And if I look at the part here, 5 to the exponent 3 gives me an answer of 125. So I know that the log base 5 of 125 is equal to 3. And so my result is 3/2. Okay, so let's take a look at another example. This one again asks us to evaluate. And so again, we're going to use some of the logarithmic powers that we know, or rules that we know. And what you'll notice here is that I'm looking at log base 3 of the 5th root of 9. So again, I'm going to look at how to write this as a rational exponent instead of in radical form. And I get log base 3 of 9 to the exponent 1/5. And so now I can apply the power law of logarithms and rewrite this as 1/5 log base 3 of 9. And I know that 3 to the exponent 2 gives me a result of 9. So I know that this is 1/5 times 2, which then simplifies to 2 over 5. Okay, let's take a look at part B. I have 4 log base 2 of 2 to the exponent 3. Now this one, I don't actually need to apply the power law. There is another way of doing this one as well. I already know that the base of my logarithm is the same as the base of the answer part here. So I know that the exponent that I need to apply to 2 to get 2 to the exponent 3 is an exponent of 3. So this one is just 4 times 3, which gives me an answer of 12. Now if I use the power law of logarithms, the coefficient is already 4. I can bring this exponent down and write it as a coefficient of the logarithm. So that would be a 3 here. And then log base 2 of 2. And so this gives me 4 times 3 times the exponent that I need to apply to 2 to get an answer of 2 is an exponent of 1. And so that gives me a result of 12. So there's another way of doing the exact same problem. Okay? Okay, so last one, for example 2, we have log base 4 of 64 plus log base 2 of 16. So these are 2 separate logarithms, and so we actually need to evaluate these individually. So for the first one, I'm trying to figure out 4 to what exponent will give me an answer of 64. And so I know 4 squared is 16, 4 to exponent 3. So I know the answer here will be 3 plus log base 2 of 16. So I need to figure out what exponent I need to apply to 2 to get a result of 16. And I know that's an exponent of 4. So 2 to the exponent 4 equals 16. So that's how I got the exponent part there. And so the final result is equal to 7.